Guys, today we looked at the Geometry 2 final exam scores from one of my classes, and we separated it by gender. And we made separately a dot plot for the distribution of scores for the females in the class, and a dot plot for the distribution of scores for the males in the class. One of the things that I want you to see is an alternative way to present this quantitative data, and it's by doing something called a back-to-back stem and leaf plot. So these values here are the stems. They represent the tens place of the percentage, of the percentages that we want to describe. So these here are the leaves. So these represent the ones place of the percentages that we want to describe. So it's called a stem and a leaf plot because together the stem and the leaf make an observation. So for instance, this 8 and this 2 together, a stem of 8 and a leaf of 2, that actually represents a stem of 8, a leaf of 2, that represents an 82% on the Geometry 2 final exam. So that 82%, when you write this showing that a stem of 8 and a leaf of 2 equals an 82%, we call this a key. So when you create a stem and leaf plot, you always want to include a key. And something special has been done here. So look, in the dot plots above, we grouped our dots by classes of size 10. So these are the percentages in the 60s, the percentages in the 70s, the percentages in the 80s. So notice that the stems, though, I've split. So in other words, this 4 represents percentages in the low 40s. This 4 is for the percentages in the high 40s, low 50s, and high 50s. Let me be more specific here. So these two 6s, and this is the Geometry 2 exam scores for the males. Let me explain. The low 60s, by low 60s, the scores that would fit into the low 60s, that would include exam percentages of 60%, 61%, 62%, 63%, or 64%. So notice there are 5 percentages that we would consider the low 60s. 60%, 61%, 62, 63, 64%. So next to this stem, the leaves that we would include would be 0, 1, 2, 3, and 4, the ones place. So here, the upper stem represents the high 60s. So the high 60s, that includes 65%, 66%, 67%, 68%, and 69%. So notice there are 5 different test scores that can be included there. So the leaves in the upper 60s would be 5, 6, 7, 8, or 9. So this graph uses what we call split stems. And when you split the groupings into the lower 60s, the higher 60s, the lower 70s, the higher 70s, you see a little bit more detail in the graph. So we call this splitting the stems. So if you actually look at the data for the males, here is the data table from the front page. So notice there are scores of 60, 60, and 64. So those leaves of 0, 0, and 4 would be in the low 60s. There they are. So there were 2 scores in the upper 60s, the 66 and the 68. So that explains the leaf of 6 and 8. There are no leaves in the 70s because no one scored in the 70% range. The 82 and the 83, that explains these leaves here. Here's 85 and 88%. There they are in the data set. And then the last 3 scores are 90, 95, and 95. So here's the 90, and then 95 is actually in the upper 90s, so those 2 5s go right here. So same thing. Here is the dot plot of the same data. So in the dot plot, one of the things we mentioned was the most important thing to notice is the gap in the 70s that separates the group of students that earned scores in the 60s versus the group of students that essentially were the A's and the B's on the final exam. You can see the same thing In a stem and leaf plot, if you turn this graph on its side, so notice I can still see the group of students in the 60s, I can still see the gap in the 70s, and here are the students that earned the A's and the B's. So the nice thing, though, about a stem and leaf plot is you can still, within the visual representation, you can still see the values in the data set. So for instance, this stem of 0 and this leaf of 6 represents a score of 60%. The stem of 9 and the leaf of 5 represents a score of 95%. In a dot plot, you can't see the data. The data are essentially hidden by the dots. In this plot, you can actually see the original values of the data set, which makes a stem and leaf plot particularly convenient. So let's plot the data for the females. So understand there was one female that scored 18%, which is relatively low, and that's okay. So we considered this an outlier, so I didn't want to have to make stems all the way back into the teens. So we know we have an outlier. So I'm gonna actually admit that over here. So we are not graphing. So the graph is missing the outlier. So we're missing the outlier at 18%. But we'll go ahead and graph the other values. So if we go back to the data set, the next value would be 43. So that leaf of 3 goes in the low 40s. So here's the low 40s. I would put a leaf of 3 here. So notice this looks kind of funny, but that does not represent a score of 34%. You always read the stem first and the leaf second. So this is a score of 43%. So there are no scores in the upper 40s. So the next score was a 53. So a leaf of 3 will go in the low 50s. So the next score, there is one score in the low 70s, so I have a leaf of 4 there. There are 2 scores in the high 70s, so I need a leaf of 7 and 9 there. So I have a 4. Then here I need a 7 and a 9. There's the 74%, the 77%, and the 79%. 74, 77, and 79%. There are 2 leaves in the low 80s, 80 and 84%. So in the high 80s, that would include the 85 and the 89. And now we get into the 90s. So there are 2 91s and a 92. 91, 91, and 92. And then the last leaves, there are quite a few here. There's a 95, 2 97s, and 2 99s. 95, 2 97s, and then 2 99s. So again, the nice thing is I can still see the data set even when I am looking at this distribution. I can see the actual values in the data set. If you go back to the original graph for the how well the females scored, all you see are the dots. You don't actually see the actual values of the exam scores. You can actually see that when you look in the stem and leaf plot. So something to be a little bit careful with when you're working with a stem and leaf plot. So notice the shape of this graph, like we talked about in the dot plot, this graph is definitely skewed to the left. It is stretched out to the left. So be careful. If you take this stem and leaf plot and simply turn it on its side, be careful. This suddenly looks like a graph that is skewed to the right or stretched to the right, but that is not true. This is still a graph that is stretched to the left. And the reason is because, notice, the stems are in the wrong order. So these are the higher values, these are the lower values. So essentially we've taken the number line and the number line is reversed. The lower values should be on the left, the higher values should be on the right. So that's not what we see here when we turn it on its side. So when we turn this on its side, I think of this as skewed towards the lower values. It is skewed towards the lower values. That means this graph is still skewed to the left. That is still a left skewed graph. just like up here, it was a little bit easier to see when the percentages are in the correct order. It is skewed towards the lower values, but in this way, it's easier to see that it's skewed to the left. So it's perfectly fine to turn a box and rather to turn a stem and leaf plot on its side to get some idea of what the shape looks like. Just be careful. So if you look at the data on the right side of this plot, the lower numbers are correctly on the left, the higher numbers are correctly on the right. So skewness and the direction of skewness can be analyzed in a normal way. But if you are looking at the data on the other side of the stem and leaf plot, on the left side of the stem and leaf plot, you have to be careful because the stems are reversed. So the lower numbers are on the right, the higher numbers are on the left. So this really does represent a skewed left graph. It is skewed towards the leftmost numbers, the leftmost observations in this data set. So this is called actually not just a stem and leaf plot, but this is a back-to-back stem and leaf plot. And it's a particularly convenient graph in order for making comparisons because the two data sets that I want to compare are already on the right and on the left. And in fact, because I'm using the same set of stems in the middle, they have, if you will, similar scales. It's easy to make them comparable because they're right next to one another. So this is not just a stem and leaf plot. Technically, this is a back-to-back stem and leaf plot. All that means is we are graphing two distributions that we want to compare back to back by using the same group of stems. So this is a back-to-back stem and leaf plot. Graphed just like any other type of stem and leaf plot.